This video will explain the math behind the examples, so that you will gain a greater understanding of why the examples work out. So let's get started now on MathCat. 3, 2, 1. A fraction is in simplest form when it is a proper fraction and there are no numbers that will divide evenly into both the top and bottom numbers. 3/8 is a fraction in simplest form. If we took a fraction like 4/6, it's a proper fraction in that the top number is smaller than the bottom number, but the number 2 will divide evenly into 4 and into 6. That looks like this. And if we divide 4 by 2, we get 2, and if we divide 6 by 2, we get 3. 2/3 is a fraction in simplest form. There's no number that will divide evenly into both 2 and 3. An improper fraction can always be simplified. Written as a mixed number, it is in simplest form. In this case, 1 and 2/30. However, there is a number that will divide evenly into 2 and into 30, and that is the number 2. So in simplest form, the top 2 divided by 2 is 1, and the bottom number, 30 divided by 2, is 15. In simplest form, 32/30 is 1 and 1/15, a mixed number written in simplest form. How do we test a fraction to see if it's in simplest form? And the answer is it's similar to finding the greatest common factor. You have to find the prime factorization of both the top and bottom numbers. In prime factors, 15 is 3 times 5. And in prime factors, 22 is 2 times 11. When we find the greatest common factor, we look for numbers that appear in both lists. To see if a fraction is in simplest form, what we're looking for is to see that no number appears in both lists. In other words, 15/22 is in simplest form, and we know it's in simplest form because when we get down to the prime factors, there are no common prime factors. So we can say that 15/22 is in simplest form because they don't share any prime factors. Let's test a fraction like 28/54 to see if it's in simplest form. Let's do prime factor trees for both 28 and 54. 28 is 2 times 14, and 14 is 2 times 7, and these numbers are all primes. 54 is 6 times 9, 6 is 3 times 2, and 9 is 3 times 3. And these are all prime factors. Let's look over our list now and see if there's any number that appears in both lists. Well, we have a 2 here and a 2 here. We have a 7, no 7s here. We have a 3 and no 3s here. So the only common number to both lists is one of these 2's. Therefore, 28/54 as a fraction is not in simplest form. It shares 2 as a prime factor. How do we make it in simplest form? We simply divide by all the common factors, in this case 2. And when we divide 28 by 2, we get 14. When we divide 54 by 2, we get 27. And 14/27 is in simplest form. Let's test 24/36 to see if it's in simplest form. We'll do prime factor trees for both 24 and 36. 24 is 8 times 3. It's 6 times 4. It's 12 times 2. It doesn't matter what we start with. We're going to end up with the same prime factors at the bottom, perhaps in different order depending on where we start. But we'll always get the same prime factors. And 4 is 2 times 2. Bring these numbers down. Let's do a prime factor tree for 36. Let's start with 12 times 3, or 9 times 4. It really doesn't matter. 12 is 6 times 2, and 6 is 3 times 2. And those are the prime factors for 30. Let's see if we have common factors in both lists. Well, we do. We have a 2 here and a 2 here. So that's 1. So we'll write down 1, 2. We have another 2 and another 2. So we'll include that. We have another 2 and no more 2's. So we don't use that 2. We have a 3 and we have a 3. So we'll include that. We have another 3, and over here, no more 3's, so we don't use that one. So we can divide both the 24 and 36 by 2 times 2, which is 4, and 4 times 3 is 12. So in fact, we can simplify 24 over 36 by dividing both numbers by 12. And 24 divided by 12 is 2, and 36 divided by 12 is 3. So in simplest forms, 24 over 36 is 2 over 3. Let's find out if 28 over 45 is in simplest form. We'll do prime trees for both 28 and 45. And 28 is 7 times 4, or 14 times 2. And 4 is 2 times 2. And over here, 45 is 9 times 5. And 9 is 3 times 3. And those are the prime factors for 45. Let's see what factors we have common to both lists. Well, we have 2's in this list, but we don't have any 2's in this list. We have 3's in this list, but we don't have any 3's in this list. We have a 5 here, but no 5 here. We have a 7 in this list, but no 7 in this list. So we do not have any common prime factor. Therefore, we say that 28 over 45 is in simplest form.